Welcome to the DIY Honda Garage channel. This presentation focuses on diagnosing DTC P0171, which indicates that the fuel system is running too lean in the 2015 to 2020 Honda Fit. A lean fuel condition means that there is not enough fuel in the air-fuel mixture entering the engine for optimal combustion, which can lead to performance issues, increased emissions, or even engine damage. Identifying the root cause of this condition involves checking various components within the vehicle's fuel and air management systems. It is important to adhere to the troubleshooting steps and avoid clearing the code prematurely, as vital diagnostic information may be lost in the process. Components affected by this condition might include the mass airflow MAF sensor, oxygen sensors, fuel injectors, and vacuum lines. Therefore, a systematic approach is essential for an accurate diagnosis. DTC P0171 indicates that the fuel system is operating too lean, meaning the amount of fuel is insufficient for the air entering the engine. This typically affects components responsible for measuring air intake and fuel delivery, including the mass airflow MAF sensor, air fuel sensors, and fuel injectors. The MAF sensor is located in the air intake duct, measuring the volume of air entering the engine. In contrast, air fuel sensors are located in the exhaust stream, monitoring the exhaust to help calculate the right air-fuel ratio. Diagnosing this error involves examining the entire fuel management system, including any related hoses or connections that could impact performance. Understanding the roles and locations of these components is vital for diagnosing and resolving the issue effectively. Several factors can lead to DTC P0171. A common cause is vacuum leaks, which can allow excess air to enter the intake system, skewing the air-fuel mixture ratio. Another potential culprit is a faulty mass airflow MAF sensor, which may misread the amount of air entering the engine, leading to insufficient fuel delivery. Damaged or clogged fuel injectors can disrupt fuel flow, while issues with air-fuel sensors that monitor exhaust gases may also contribute to the lean condition. Each of these components plays a critical role in maintaining the proper air-fuel balance, and diagnosing them accurately is essential for curing the problem and restoring vehicle performance. When DTC P0171 is triggered, several noticeable symptoms may arise. Drivers may experience poor engine performance, including hesitation during acceleration, rough idling, or stalling because the engine is not receiving the proper air-fuel mixture. Increased fuel consumption may occur due to the engine attempting to compensate for the lean condition. Furthermore, the check engine light will illuminate on the dashboard, alerting the driver to a possible issue that requires further investigation. Recognizing these symptoms early can play a pivotal role in maintaining the health of the vehicle's engine and preventing more severe damage due to running too lean. The first troubleshooting step involves starting the Honda Fit's engine and allowing it to idle without any load, meaning that if it has a continuously variable transmission, CVT, the gear should be in park or neutral. If it is a manual transmission, it should be in neutral as well. Using the Honda Diagnostics System, HDS, the technician will check the AFFB short-term fuel trim parameter. If the value exceeds 1.33, it indicates that the fuel trim level is too high at idle, confirming a lean condition issue. In this case, the troubleshooting process continues to the next step. However, if the AFFB value is acceptable, the system is operating normally in this condition, and further diagnosis may not be necessary. In the second step, the technician must review the onboard snapshot data captured while the AFFB short-term fuel trim was at its maximum during the previous idle check. This information is critical for understanding the vehicle's operating conditions when the issue occurs. Parameters to record from the snapshot include engine speed, vehicle speed, relative throttle position, and accelerator pedal position. By driving the vehicle under the conditions noted in the onboard snapshot, the technician can gather further data. During this drive, the AF/FB value is monitored once again with the HDS. If it still exceeds 1.33 under these conditions, this further confirms that the fuel system is lean. Otherwise, it suggests that the issue might not be consistent. The third step involves checking the mass airflow MAF sensor, a vital component that measures the amount of air entering the engine. The technician starts by turning the vehicle to the off position and removing the MAF/IAT sensor. Once the sensor is accessed, it must be examined for debris, such as lint or insects, which can obstruct airflow and affect readings. Any debris found should be carefully removed, and it's also beneficial to use a vacuum cleaner to clean out the air cleaner housing, ensuring optimal airflow to the engine. If no debris is found, the technician can then reinstall the sensor and proceed to the next troubleshooting step. Cleaning the MAF sensor can resolve false lean readings and restore proper function. In Step 4, the technician conducts a visual inspection of several components that could affect the air-fuel mixture. Key areas to examine include the crankcase breather hose, the air cleaner housing, the oil cap, and the dipstick. Each component should be inspected for any signs of disconnection, cracks, or damage. If any of these components are compromised, they could allow unwanted air into the intake system, which would contribute to a lean condition. If any defects are found, repairs should be made immediately. If all components are intact and functioning properly, the technician will proceed to the next step in the troubleshooting process. The fifth troubleshooting step requires starting the engine again and letting it idle. The technician will then pinch the brake booster vacuum hose, which is connected to the intake manifold, while monitoring the AF/FB short-term fuel trim with the HDS. Pinching the hose isolates the brake booster, preventing any vacuum leaks from affecting the intake air measurement. If the AF/FB value remains above 1.33, it indicates that the brake booster or its associated hoses are not leaking, allowing the technician to proceed. However, if the value decreases, it suggests that there is a vacuum leak within the brake booster or its hoses, necessitating further inspection and potential replacement. During Step 6, the technician continues to let the engine idle and proceeds to pinch the positive crankcase ventilation (PCV) vacuum hose. Monitoring the AF/FB short-term fuel trim in this scenario is crucial. This step allows the technician to assess whether a leak exists in the PCV system. If the AF/FB value remains above 1.33, it means the PCV system is holding vacuum properly and no leaks are present. Otherwise, if the AF/FB value drops, it indicates a potential vacuum leak in the PCV system that needs further inspection. Addressing any leaks found is crucial to restore proper operation and ensure the engine management system functions as designed. The seventh troubleshooting step involves holding the engine speed at 2,500 RPM while monitoring the MAF sensor reading with the HDS. This test must be performed under certain conditions, including ensuring the engine coolant temperature (ECT sensor 1) reading is above 158 degrees Fahrenheit or 70 degrees Celsius. The gear is in park or neutral, and all electrical loads are turned off. The technician will check if the MAF sensor value falls within the specified range, which is typically between 3.8 to 5.4 grams per second for manual transmissions, or 3.9 to 5.5 grams per second for continuously variable transmissions, CVT. If the readings are acceptable, it indicates that the MAF sensor is functioning properly, leading to further troubleshooting steps. Should the readings be out of the specified range, it may signal a defect in the MAF sensor or its installation that requires inspection or replacement. In Step 8, the technician needs to measure the low fuel pressure while the AFFB, short-term fuel trim, is observed to be 1.33 or higher. Understanding the fuel pressure is crucial for diagnosing a lean condition. The acceptable range for fuel pressure is between 395 to 405 kilopascal, equivalent to 4.0 to 4.1 kilograms of free points squared, or 57 to 58 psi. If the fuel pressure falls within this range, it indicates that the low fuel side is functioning correctly, and the technician can proceed to the next step. However, if the fuel pressure is outside this range, it may suggest issues with the fuel pump or other fuel delivery components. In such cases, checking power supply and grounding to the fuel pump will be necessary. If these checks are satisfactory, the technician should consider replacing the fuel tank unit. The 9th step involves assessing high fuel pressure. The technician starts by turning the vehicle to the on mode and clearing the DTC with the HDS, Honda Diagnostic System. Afterward, the engine is started and held at 3,000 RPM without load until the radiator fan engages, then allowed to idle. Using the HDS, the technician selects the DI fuel pressure test from the inspection menu to assess whether the fuel pressure is normal. If the HDS indicates normal fuel pressure, the low pressure side can be ruled out, leading the technician to check for other potential causes. Conversely, if abnormal pressure readings are detected, troubleshooting should refer to DTC P0087 and P0088, which pertain to fuel rail pressure issues. Proper evaluation of high fuel pressure is necessary to pinpoint fuel delivery problems effectively. Step 10 suggests that fuel quality might be contributing to the lean condition. If the lean condition became evident soon after refueling, there's an increased likelihood of fuel-related issues. The technician will drain the existing fuel from the tank and refill it with known good fuel from a reputable source. Following the refueling, the vehicle should be operated under conditions that triggered the high AFFB, short-term fuel trim, reading. By monitoring the AFFB once again during driving, the technician can determine if the fuel quality was the root cause. If the AFFB still indicates a lean condition, this implies the fuel quality is not to blame and further troubleshooting must continue. However, if it drops back within the normal range, then it confirms that the initial fuel caused the high readings. In Step 11, the technician is tasked with checking for any potential intake manifold vacuum leaks that could contribute to the lean condition. This process begins by disconnecting the intake air duct from the air cleaner housing, followed by connecting a large intake manifold adapter cone if available. If not, the technician can leave the duct connected but remove the brake booster vacuum hose and inject smoke into it. The purpose of this is to use the OTC LeakMaster Evaporative Emission System Tester to direct smoke into the manifold and identify leaks. Visual inspection focuses on the intake manifold, throttle body, air ducts, and associated vacuum hoses. If any leaks are detected, repairs should be made to prevent excess air from entering the system. If no leaks are found, the technician can then reconnect components and advance to the next troubleshooting step. Step 12 involves replacing the fuel injectors if they are suspected of being faulty. For this step, the vehicle should be turned off and the existing injectors need to be replaced with a set of known good injectors. After replacing the injectors, the technician will need to start the engine again and operate the vehicle under the same conditions that previously exhibited high AFFB, short-term fuel trim values. Monitoring the AFFB again during this process is essential. If the AFFB value remains too high, this suggests that the injectors were not the cause of the problem, prompting further investigation. However, if it indicates a normal level, it would confirm that defective injectors were responsible for the lean condition, addressing part of the issues leading to DTC P0171. In the final troubleshooting step, if all previous attempts do not resolve the issue, the technician should replace the air-fuel sensor, AF sensor, located in the exhaust system as sensor 1. After replacing it with a known good sensor, the technician restarts the engine and operates the vehicle under the same specific driving conditions monitored previously. Once again, the AFFB parameter is checked to see if the readings have returned to a normal range above 1. If the readings remain high after replacement, it would indicate that the new AF sensor is functioning correctly and that the issue lies elsewhere, possibly necessitating a check of the powertrain control module, PCM. Conversely, if the AFFB returns to appropriate values, it confirms that the original AF sensor was defective, resolving the lean system error effectively. After all troubleshooting and repairs are complete, it is essential to conduct a final verification for DTC P0171. The technician should ensure that all repairs have been executed as per the diagnosis and recheck the vehicle using the HDS to scan for any new or remaining DTCs. This ensures that no other underlying issues were overlooked during the process. If DTC P0171 or any other codes appear, further investigation may be necessary. Upon confirming that no DTCs remain, a test drive should be carried out under normal driving conditions to assess the overall performance of the vehicle. Successful verification indicates that the issue has been resolved and the vehicle is ready for use. Preventive maintenance can significantly reduce the likelihood of encountering DTC P0171 in the future. Regular checks of the air intake system can help ensure that the MAF sensor remains clean and doesn't get obstructed by debris. It's important to clean or replace air filters as needed to maintain optimal airflow. Additionally, routinely inspect fuel system components such as the fuel injectors, AF sensors, and vacuum hoses for signs of wear or damage. Addressing potential issues early can prevent more serious problems down the road. Keeping records of maintenance and repairs can aid in recognizing patterns and improving the vehicle's reliability overall. In conclusion, diagnosing DTC P0171 Fuel System 2 Lean in the Honda Fit involves a thorough investigation of several systems and components integral to engine performance. Understanding the roles of the MAF sensor, AF sensors, fuel injectors, and various vacuum hoses is crucial for accurate diagnosis. Following a logical troubleshooting procedure can help identify the root causes of the lean condition and lead to effective repairs. Moreover, preventive maintenance is vital to avoid future errors and keep the vehicle running efficiently. Finally, if all steps are followed diligently, the chances of resolving the lean condition and restoring optimal performance are significantly improved. Please like and subscribe to the channel. See you next time.